Alright, so in this video we're going to be going over derivatives and the difference quotient, as well as the alternate difference quotient. So first off, let's talk about the difference quotient. So the difference quotient can be expressed as with a limit first as h approaches 0. And some of you may have seen this before. This is what the difference quotient essentially is. It's as the limit of h approaches 0, it equals f of x plus h minus f of x divided by h. This may sound very foreign so far, but let's go over an example first. So suppose we have the function f of x x squared minus 3x plus 4. And we want to know what f of prime 2 equals. By the way, I should have discussed this earlier. The difference quotient, it shows us how to find the values of the functions in their derivatives. So whenever you see f of prime of 2, that's basically saying what is the derivative of f of x, and then you plug in 2 into that function. Well, it's kind of hard to explain right now, but we'll get into that. We'll get deeper into that a bit later. But let's just apply this formula. Hold on. So we do have this formula, and we know what f of x is. It's right here. F of x is given to us, and h, we can just leave it as h for now. F of x h, though, this is the main problem we're gonna have to figure out. But to do that, you can just put this to the side. You would literally have to plug in x plus h into the function f of x. So let me show you what that looks like. That's what you do. You get your little box here. X squared, xh, xh, h squared. So you end up with x squared plus 2xh plus h squared. Let's erase this for now. It's taking up a bit of space. And you can distribute these. You can distribute -3 into x plus h. You get -3x, -3h, plus 4. And this is essentially what f of x plus h equals. So now we can plug this into our little formula here. So say we have this entire equation we just derived, sort of. What this represents, let me erase this. We don't need this formula right now. What this area represents is f of x plus h. And of course, we're going to subtract f of x, which we're already given. This entire thing represents f of x. And then we just have h at the bottom. This is just h. But you don't really need to memorize that. So you can kind of see how this is going hand to hand with the formula already. You can kind of see how this is going hand to hand a little bit. So now we can combine like terms in the numerator. So what you're gonna have to do here, let's do this. So you distribute the negative, obviously. X squared minus x squared just cancels out, that's 0. 2xh, let's put this on this side over here. We're left with 2xh, because there isn't another xh in the numerator. H squared, we're left with h squared as well. There's no other h squared. 3x, negative 3x cancels out. Negative 3h stays. And then the 4's cancel out. This is what we're essentially left with. Now, here, you can factor out the h's. Whoops. All right, let's make sure I don't forget what I wrote. I think this is what I had, yeah. Okay, so you can factor out h from the numerator, and then you can cancel them out from the denominator. So you're left with this. You're left with 2x plus h minus 3. And this is essentially your derived equation from the difference quotient. So now you can plug in f of 2. When you do that, you have 2 times 2 plus h, or actually h is 0, and I'll explain why, minus 3. So the reason why h is 0 is because, remember, we have this limitation as h approaches 0, right? For our difference equation here, right? We're evaluating f prime of x when h is approaching 0. So h has to equal 0 in this problem here. So you put these together, you have 4 minus 3, that gets you 1. So in the end, f of prime of 2 equals 1. That's the difference quotient. There's also an alternate difference quotient, which is a little more straightforward. But the alternate difference quotient is basically saying, as x approaches a constant c, f of x minus f of c is over x minus c. So now let's say we're trying to solve for f prime 2 when we have f of x equals x squared minus 3x plus 4. So let's do that. Plugging it into c, 2 equals c, because that's what we're trying to solve for. So what you're going to do here, and you're going to solve for f of 2, just f of 2. Not f of prime 2, but f of 2. Let's see. 4 minus 6, negative 2 plus 4 is just 2. And then you got x minus 2 here. Then what you're going to do, you're going to combine like terms. You're left with x squared minus 3x plus 2. what you can do here, you factor. You factor there. These cancel out, and you're left with x minus 1. This, whoops, hold on. This is your derived equation. And what you can do here, all you have to do here now, plug in f of prime 2. Got 2 minus 1. That gets you 1. So they both get you the same answer. So that's the difference quotient and the alternate difference quotient. As long as you know how the formulas work and how to apply them, it's not too hard. Okay, so for derivatives, the main thing you have to know is that there's the power rule, the product rule, the quotient rule, and the chain rule. The power rule is the most crucial rule, and it's the rule that you're going to need to know first. So what you're going to have to do here, notice ax to the power of n, right? To find the derivative of that, this is the power rule. The derivative of a times x to the power of n is a times n times x to the power of n minus 1. You see what we're doing here? Say we had 2x squared. The derivative of that would just be 4x. Because 2 minus 1 is just 1, so you don't really have to put a power there. You can put 1 to the power of 1 if you'd like to, but there's not really any point, same meaning. And then it's a times n. This 2 is n, this 2 is a. You're basically multiplying them together to get 4. That's basically how it works. Let's try a more complex example. All right, use the power rule. You can pause this video if you want, but use the power rule to solve for this equation, to solve for the derivative of this equation. Okay, I'm gonna do this myself. So, referring back to this formula, you are going to, first of all, bring the 3 down here, multiply it with 4/3. That gets you 12 over 3, which is just 4. So let's put this up here. Whoops. Up here a little bit. 4x squared, which is what we have. And then for 6x, you're bringing the 1 down here, multiply it by 6, you get 6. But you don't have x. The derivative of 6x is just 6 because this power is now going to be 0. So x to the power of 0 is just 1. That's being distributed to the... That's just x to the 0th power, which is just 1. So that leaves you with 6. And then the derivative of 5. This symbol, by the way, is just the derivative of this number next to it. The derivative of 5 is just 0. Any number that is just a constant, like 1, 2, 3, 4, 5, the derivative of that number is just 0. And so you have your derived equation. So the product rule states that the derivative of h of x, or h prime of x, is equal to f of x times the derivative of g of x plus the derivative of f of x times g of x. This is essentially what the power rule is stating. I mean, the power rule, product rule. By the way, in the product, quotient, and chain rules, you are going to be applying the power rule. Chances are you will be applying the power rule in the middle of the process. It may sound like a complex process, but I'll simplify it for you as we go through this. So say we have, whoops, let's call this h of x just to simplify it. H of x equals x squared plus 6 times 2x5. We want to find the h of prime x, or in other words, the derivative of h of x. So let's do this. First off, we need to apply the power rule. We have to input that into both here. By the way, you can think of it this way. This part of the equation, you can assign the f of x. This part of the equation is g of x. So g of x is equal to 2x minus 5. F of x is equal to x squared plus 6. So apply the power rule to there. You end up with, let's color code this a little bit actually. So f prime x, you end up with 2x. And then g prime x, you end up with just 2. Step 2, now you apply the product rule. So let's do this. We have h of prime of x equals, let's see, f of x, which is x squared plus 6 times g prime of x, which is just 2. Whoops. And then you have f prime x, which is just 2x, times g of x. You can distribute them. 4x squared minus 10x, and then you can combine like terms from here. Let's see. 6x squared minus 10x plus 12. That's your derivative. You don't have to use the power rule here to overcomplicate things. This is your derivative. That's how you use the product rule. Okay, now moving on to the quotient rule. Now the quotient rule is a little hectic. Obviously, we're going to be dividing. So it's basically stating that h of prime x of x equals g of x times f prime x minus f of x times g prime x. Or divided by g of x squared. This is what it's stating. And like in the product rule, you will be using the power rule in the process. That's why the power rule is so crucial to know. You have to know it to solve the other rules. So, using the quotient rule, let's try to find the derivative of 3x plus 7 over x squared minus 1. Oh, by the way, just so if you're confused which one is f of x and g of x, this is what you're going to want to use. F of x is in the numerator, g of x is in the denominator. Okay, so, oh wait, hold on. Probably better if I rename this to h of x, just so we don't overcomplicate things. Okay, now we want to find the derivative of h of x, or in other words, d over d of x of h of x. So let's do this. So as we follow the rule, g of x, which is equal to x squared minus 1, is right here. And you're probably going to want to put x squared minus 1 squared. Now let's solve first rule. First step is to apply the power rule. So when you apply the power rule, you get f prime x is equal to 3. G prime x is equal to 2x. Now we can use the quotient rule to solve for this. So let's do this. You got x squared minus 1 plus 3. Then you got minus f of x, which is 3x plus 7. Times g prime of x. Let's erase these. Okay, now you're going to want to simplify this. So you have 3x squared minus 3. It's one part. And you got 6x squared plus 14x. For x squared minus 1, you can kind of just plug that into here. Got x to the 4th minus 2x squared or plus 1. Then you just add these together. You have, let's see. Oh wait, you subtract these together, never mind. So then you have negative 3x squared minus 14x. And then you would have minus 3. And then, believe it or not, this is your final answer. It doesn't look like it, but this is your final answer. This is h of prime of x. So that's how you apply the quotient rule. You can simplify this if you want to and if you can, but you wouldn't need to unless your teacher wants you to. Now let's go over the chain rule. Okay, so the chain rule states that h of prime x, as you guessed, is equal to f of prime of g of x times g prime of x. Yep. So this formula kind of throws you off a little bit because now we're dealing with function composition. You can see how that's working now, yeah. Oh, and before we dig in deep into solving for an example, I want you guys to know this, to know these following formulas. So the derivative of log base a of f of x is equal to 1 times lane a times f of x and times that by f prime of x. And then the derivative of a to the power of f of x is equal to lane a times a to the power of f of x times f prime of x. You can go ahead and screenshot this if you want to. We're not going to delve deep into these things today. I'm just giving you guys these formulas just so you can reference to them later on. These will be important. And another thing you want to keep in mind, you probably heard of this anyway, but the derivative of e of x is still e of x. Just remember that. It doesn't change. Okay, now let's get into the example. So say we have h of x equals the square root of 3x plus 1. We want to find the derivative of h of x. Now, here's where it gets tricky, because you need to identify what is f of x and what is g of x. F of x, if you can guess, is the square root of x, because we're square rooting this whole thing. Whoops. G of x is equal to 3x plus 1. You understand how that works? Because we're basically, you can think of it this way. We're square rooting 3x plus 1, this polynomial, or this binomial. We're square rooting it. That's kind of like composition. That's why function composition is an important topic to learn in pre-calculus, because it prepares you for AP calculus, specifically for the chain rule. Anyways, let's solve this. So let's refer back to this formula. First, you want to find the derivative of both. So what you're going to have to do, applying the power rule once again, we know that the square root of x is just equal to x to the power of 1/2. And finding the derivative of that is just 1/2 x to the power of negative 1/2. Because that's 1/2 minus by 1. Yeah? And this equals f prime of x. For g of x, it's more straightforward. It's just 3. Alright, now let's solve through this. Now we can apply the chain rule. So, f of prime of x, which is 1/2. Let's color code this actually a little bit. 1/2 times g of x, which is 3x plus 1. To the power of negative 1/2 times, keep moving this thing around, times 3. You can go ahead and solve this on your own. And pause the video here. Okay, so one thing that I did forget to go over is that to simplify this, 1/2 x to the power of negative 1/2, it's basically the same thing as 1/2x to the power of 1/2, which is also equal to 1/2 times the square root of x. So you could kind of think of it that way. As a matter of fact, I think it's easier to think of it this way. So this would actually be 1/2 to this of the square root of 3x plus 1. You could do it however you want to. This is just an easier, more simple method. But basically all you have to do here, just multiply these two together. And that is your derivative using the chain rule.